What's poppin', dogs? Mr. Allen here, about to graph some trigonometric functions. For this one, we got y equals -2 times the sine of theta plus pi over 2 minus 4. So the first thing I like to do is jot down my amplitude, period, midline, phase shift, if there is one, and then I'll plot my midline. So my amplitude here is 2, all right? Now, even though there's a negative there, that's just gonna be a reflection essentially, or it's gonna start by going down from the midline since it's a sine function. So the negative is its own separate dealio. Now for the period, since there's nothing multiplied to the theta inside of that sine function, the period is just 2 pi. Now my midline has to deal with that number that's on the outside, the -4. It's gonna shift down 4, so my midline is y equals -4. Now for the phase shift, that's what's adding or subtracting on the inside of the sine function. Since I'm adding pi over 2, I'm going to go left pi over 2. So left pi over 2. Remember, it's opposite on the inside. All right, so now I'm ready to put my midline down. So I'll use this ruler here. I'm going to go down to -4. We'll just assume that these are going to go by ones, right? If I was going to be going by like halves or twos, then I would write it all out. But because I'm going by ones, we'll just count it, all right? So let's put our midline down here. Lovely, nice and dashed. Some teachers require it, not everybody does, but I'm gonna go ahead and throw it down. All right, now, let's see here. Let's do a different color for the actual graph. I'll go pink for this. So a sine function starts on the midline, okay? On the midline, whereas cosine starts above or below the midline if it's positive or negative out front. So since the sine function starts on the midline and I've shifted left pi over 2, my first point is gonna be right here on the midline at -pi over 2. And from here, I'm going to either go above or below the midline by the amplitude, which is 2. So since it's -2, I'm going to start by going down 2, and then back up to the midline, and then now I'm going to go above the midline, and then back to it. All right, so it follows that pattern. If I'm on the midline, I need to either go above or below. And if I'm below the midline, like I was for that second point, I got to go back to the midline, and now I'm going to go above because last time I was below. So you get that little, squiggly shape there, okay? So this is one full period, and I'm going to go ahead and fill this guy in, and we want to be nice and curvy if possible. No sharp, I just like whistled there. No sharp turns, and there we go, we got our arrows on that. So a lot of teachers will ask you to just graph one period. If they ask you to do more, you can. I will go in a dashed format now for outside of one period. So I'm just going to keep on going with that pattern where I go above, on it, below. And then since over here at the 3 pi over 2, I'm on it, I'll then go below, and that'd be back up to it. Anyways, so here we go. We got some dashed lines, whee, and back up. And then I'm dashing, and back on up. Okay. So there we go. We have our solid is one period, whereas the dash stuff is just, it continues on forever. It's a sinusoidal function. So we continue, to follow this pattern forever and ever. It never ends. But there we go. We got ourselves a nice sine function that we graphed. And now we'll do another one. We'll do a cosine function for this next example. So for this next one here, we got y equals 4 cosine of 1/2 theta plus pi inside the cosine function, plus 3 on the outside. So for the first thing I like to do on this one, is because I'm going to forget otherwise, is I need to factor the inside of that cosine function. You got to take out that 1/2. Even though like pi doesn't look like it's divisible by 1/2, we're still going to factor it out, okay? And that's how we can get our phase shift correctly. Otherwise, everything's going to be correct except the phase shift, and then our graph is messed up. So here's what I mean. We got y equals 4 cosine. Then I'm going to take out the 1/2. Then I'm going to add another set of parentheses here. Theta plus, and if I divide out a 1/2, it's like I just multiplied by 2. So I'm going to put a 2 pi and then plus 3. And if you didn't quite follow that, check this out. If I were to pretend like I'm going to distribute that 1/2 back in, right? If I were to distribute this 1/2 to both, I would get 1/2 theta, that checks out, and I'd get 1/2 times 2 pi, that's going to give me 1 pi, that checks out. So I always like to double check and distribute like back in and make sure that it all is good to go, all right? So we're good on that one. Now I can properly identify my phase shift. So my amplitude, first off, is 4. The period, I'm going to get by doing a little bit of work here. I got 2 pi as my normal period. I need to divide it by the multiplier, which is this 1/2 right here. So divide it by 1/2. And to divide by 1/2 is like multiplying by the reciprocal, which is the official curly Q notation there. It's not official. All right, it is 2 pi times 2, multiplying by or sorry, dividing by 1/2 is like multiplying by 2. So I'm going to get 4 pi for my period, okay? Cool. Now, the other thing I'm going to use with that is the scaling, okay? So we usually break this thing up into like 4 sections of a graph. You'll see 4 distinct sections of a graph as we go through the motions. So I'm going to take 4 pi. I'm going to put scale down here because I have a little bit of room. 4 pi, and I'm going to divide that by those 4 sections, meaning I'm going to go by pi's, okay? So we are going to be a little bit stretched out here, right? This is a horizontal stretch of our graph. You're going to see it's going to take a little longer to go through the motions. All right, now my midline, that's the +3, so y equals 3. And then my phase shift, I'm going to be going left. 2 pi. Cool. All right, I think that's about it. Let's get it going. My ruler. Let's see here. My midline is at +3. Y equals +3, so I'm going to dash that in. Whee! Dashes along a ruler are very satisfying, Looks so straight and nice. All right, good arrows too. And now I'll go ahead with my graph. I'm going to use pink again for the graph. Let's see here. Normally cosine starts above the midline, 4 above in this case. If it were -4, it would be 4 below the midline. But I also shifted left 2 pi. So instead of being right up here, right where that pink dot is, I'm instead going to be moved all the way to the left 2 pi, and that is my first point. Now my next point will be on the midline. But how far left, right do I need to move? My scale is pi, so I'm going to go pi to the right, and then I'm going to go below the midline by 4. So I'm going to be at 0, because I'm another pi to the left, and then I'll be back to the midline, another pi to the right. I'm going to go pi to the right again, and I'll be back at the midline, and then pi to the right again, I'll be above the midline. And we get, man, that takes up the entire graph. So let's see if we can connect this in a nice, sort of curvy, whee. Perfect. It's beautiful. A wonderful cosine function that fits perfectly centered there. It's very satisfying. Okay, it was planned out well, right? Sometimes they go way off the graph and things like that, but there we go, guys. That's 2 examples there. We got a sine function, a cosine function. I mean, graphing trig is just absolutely a blast. All right, hope that helps you guys, and I got a few more videos that are coming, so make sure you're watching, liking, subscribing, sharing, and staying dope.